Hello, everyone. We have about 5 minutes until our meeting starts here, but just starting the YouTube live stream a little bit early, just to make sure that everybody can find it and they can get to the meeting on time online.
Okay, let's start, people. Take a seat, please. We're going to proceed with a different order this meeting because it is my understanding that our presenter is under a time constraint, so we're going to turn the time over to him first. Our presenter is Karl Liesel-Schwab, K9LA. He's going to talk to us about solar cycle 25 and tropospheric ducting. Karl began shortwave listening in the late 1950s. He received his novice license, WN9 AVT, in October 1961 and selected K9LA in 1977. He is an electrical engineering graduate of Purdue University and was an RF design engineer for Motorola and Magnavox/Raytheon until his retirement in 2013. He has written monthly propagation columns for World Radio and National Contest Journal, has written solar and propagation articles for many other amateur radio publications, and has contributed to several books. He was the vice director of the ARRL Central Division from 2017 to 2021. He then moved into the director position and will retire from this position as of December 31st, 1924. Carl enjoys propagation research, DXing. He is at the top of the honor roll, incidentally. Contesting. He was the editor of the ARRL's National Contest Journal from 2002 to 2007, playing with antennas and restoring and using vintage equipment. He and his wife, Vicki, enjoy traveling, which has included the expeditions to Syria, to Market Reef, and numerous trips to the Cayman Islands. Please welcome Carl Lieselschwab. Carl, I'll turn it over to you.
Good on our end. Can I trouble you for 1 second, Carl?
Sure.
All right, so I got to double check audio. It's not going through YouTube, so give me 2 seconds.
Okay. Okay.
Okay, perfect. I fixed that and we're good to go. Sorry about that.
Oh, no problem. Okay. So, uh, what are the two issues needed to make a QSO? Well, there's got to be enough ionization up in the ionosphere to refract, which is bend the signal back to Earth. Otherwise, it'll go through the ionosphere and be lost forever. Now, the higher the frequency, the more ionization is needed. And that's because the amount of refraction is inversely proportional to the square of the frequency. So the higher the frequency, the more ionization is needed. The other issue needed to make a QSO is there must be low enough ionospheric absorption, which is loss, to allow the signal to be heard, for example, on sideband and CW, or detected in the digital modes. Of course, this also depends on your noise environment. If you got a really noisy location, well, you either have to get bigger antennas, increase your transmit power. Hopefully, you got a good receiver. Most of the receivers nowadays are quite similar in sensitivity, so that's not a big issue. Your noise environment is. The lower the frequency, the more the ionospheric absorption. So the lower you go in frequency, the more loss the ionosphere gives us in the D region. That's because the amount of absorption is also inversely proportional to the square of the frequency. Okay, so let's start with medium frequencies. That's 300 kilohertz to 3 megahertz. We have two amateur bands in that range. We got 630 meters, which is around 475 kilohertz, and 160 meters, which 1.8 to 2.0 megahertz. Now, 2200 meters, that's our lowest amateur band. That's down at 136 kilohertz, around there. And that's a low frequency band, LF being 30 to 300 kilohertz. So we're not going to talk about that one. Now, 630 and 160, both of those bands are driven by ionospheric absorption in the D region. Remember I said the lower in frequency, the more the absorption, the more the loss in the D region. So that's unfortunately what happens on those bands. Now, even in the dark ionosphere on a winter night at solar minimum, there's usually enough ionization to refract the signal back, those two signals on those bands back to Earth. And unfortunately, we get more ionospheric absorption at solar maximum where we are. You could see that in that plot of cycle 25. We're at solar maximum. How much higher, we don't know. It'll probably stay in that vicinity for a year or two. Now, on those two bands, 630 meters and 160 meters, your noise environment is very important. We've probably heard about beverage antennas, four-square antennas, and other low noise receive antennas. They're used to try and mitigate man-made noise, machinery, all the electronics we have in our house and your neighbors have right now, and also atmospheric noise, like QRN from thunderstorms. Those antennas work by having directivity on those bands, and that means you can point the antenna at the desired location, and hopefully there won't be much gain from where the noise is coming. Now, man-made noise is probably one of the biggest things. Power lines, like I said, power lines, electronics, things are getting worse. There's no doubt about it. And you really have to pay attention if you want to work on those bands, especially if you want to work lots of good VX on those bands. What about HF? That's 3 to 30 megahertz. 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 9 bands on HF. The common ones, of course, are 80, 40, 30, 20, 17, 15, 12, and 10. 60 meters is channelized. So probably not as many people on 60 as all those other bands. Now, the lower frequencies, 80, 60, and 40, they're still dependent on ionospheric absorption because they're low enough in frequency to incur a good amount of loss, not as much as on 160, but they still have loss. Those 3 bands are best around solar minimum. That's not where we're at, but that's the way it goes. And those bands are generally best during the night for long distance contacts. On 40 meters, that's a good domestic band during the daytime. Okay, those intermediate frequencies, 30, 20, 17, they're not as dependent on absorptions as on the lower frequencies, and they're not as dependent on ionization as on the higher frequencies. So what happens is those 3 bands are generally good over an entire solar cycle. I've always grown up in ham radio hearing that if you can only put up 1 antenna, put up a 20-meter antenna because it'll be good throughout a solar cycle and it'll offer great opportunities worldwide, even at solar minimum. The 3 higher frequencies, 15, 12, and 10, they are very dependent on the amount of ionization. And that's because the higher the frequencies, the more ionization is needed to refract those higher frequencies back to Earth. They're best around solar maximum, where we are. Although it's a small cycle so far, it's still good enough that we have great propagation in the fall and winter months on 15, 12, and 10 meters. During the summer months, because of the change in the composition of the atmosphere, those 3 bands aren't as good during the summer months, but that's just something we have to take with because the atmosphere changes its composition. Now we're going to probably have great propagation on 15, 12, and 10 for another 2 to 3 years before cycle 25 starts going down. So get on those bands and have some fun. Techs have 10-meter privileges, so you'll have lots of fun there. And 12 meters and 15 meters, well, they're still good, but a lot of people migrate to 10 because the signals are stronger. So, okay, now all those good things about HF, well, disturbances to propagation can really screw up the ionosphere for HF propagation. And there are 3 disturbances to propagation. One is a geomagnetic storm. That comes from either a coronal mass ejection, a CME, which they're most prevalent around solar maximum, or it could come from a coronal hole. That's most prevalent during the decline of a cycle. Both of those can decrease the MUF, the maximum usable frequency that can be used, which means the F2 region is depleted of electrons. And that can degrade the F2 region for days. That is considered to be the worst disturbance to propagation, a geomagnetic storm. And the way you can detect that we're under storm conditions is the K indices will be elevated. The K index is a 3-hour index. So there's 8 of them in the day. And once they get above 6, they're on a logarithmic scale from 0 to 9. Once they get above 6, things can happen that aren't good for the F2 region of the ionosphere, which is mostly responsible for our long distance contacts. A second disturbance is a solar radiation storm. And it appears to be caused by energetic protons released by and accelerated by a concurrent big solar flare. and an Earth-directed CME. Now, what happens with a solar radiation storm is, like I said, the protons in the solar atmosphere get accelerated and head towards Earth, and they funnel into the polar cap. That's the area inside the auroral oval. And that results in weaker signals on over the pole pass because they increase the deregionization in the polar cap. And that can happen for a day or two. And a good example from Utah would be into Finland or Russia or India. That's over the North Pole. And those paths go through the northern polar cap. And if there's a solar radiation storm, that can be a problem. Now, most of your paths generally don't go through the northern polar cap. So there's still lots of other stuff that doesn't. So that's good. The third disturbance is a radio blackout. That's caused by the X-ray radiation from a big solar flare. Yeah. By the way, we have 8 cats, so you'll probably hear some here as they wander by or see their tail as, like I said, as they go by. The radio blackout results in increased ionospheric absorption on the daylight side of the Earth. The lower frequencies are affected most, and it results in weaker or non-existent signals for an hour or so. That's why it's called a blackout, because the lower frequencies can go away. And you wonder if, is my antenna still up in the air? Did somebody bite through the coax or whatever? Now, in a summary, we have to take the good, lots of ionization for 15, 12, and 10 at solar maximum, with the bad, which gives us disturbances because CMEs and solar flares are most prevalent around solar max. So we got to take the good with the bad. Thank goodness most of the time it's good, but sometimes it can be bad because of CMEs or solar flares. Now, one way to determine what the heck is going on our bands is check dxmaps.com. That's the URL, by the way. I'll be sending a PDF of this presentation, so if you want to go to that URL, you can check it out when you get the PDF. But if you go to dxmaps.com, it'll tell you what's going on right now. And here's an example. I went to dxmaps.com. I selected a view, which worldwide, you can select North America, Europe, Asia, but I selected the world view. I looked at this on today, in fact, on 10 meters. You can select 2,200 meters all the way up to UHF, 450 megahertz, by using the little icons there at the top left. Now, this was from 1543 to 1545 UTC, which is around 8:45 a.m. Mountain Standard Time. And you can see 10 meters was doing pretty good into Europe, doing good into South America, into the eastern part of Africa. Japan is in darkness, so you weren't going to have any QSOs with Japan, but more than likely there's some good ones at night when you hit night, and Japan hits sunrise. So this is a very nice tool that tells you who's working who and what it is. It comes from spots on the internet, and they take the 2 spots, draw a great circle path in between the 2, and that's what you're seeing. A bunch of great circle paths from one station to the next station. And if there's lots of activity like here, it's time to get on 10 meters. 12 and 15 probably were doing real good too. Now, there are other methods besides dxmaps.com. There's WhisperNet, PSK Reporter, the IARU Northern Cal DX Foundation beacons, the Reverse Beacon Network, and some others. So there's lots of ways to see what's going on right now in with the ionosphere on each of our bands. So, if you go to one of those and you don't see anything, that kind of says, well, it's probably not even worthwhile of turning the band switch. Although sometimes it may help just to call CQ and see what happens. Okay, now let's get into VHF, which is 30 to 300 megahertz. We have 3 bands in VHF. We have, of course, 6 meters. We have 2 meters, and we got 220 meters, which is, or 220 megahertz, which is 1.25 meters. Now, for these bands, we have to look at terrestrial weather and also space weather. Okay, so what is terrestrial weather? Well, that's when the sun heats our atmosphere, and the result is weather in the troposphere. The troposphere goes from ground level to about 11 kilometers, which is 30,000 feet. You can see that in that little temperature versus altitude plot on the right side of the slide. And what you can see is in red, the temperature. You can see from ground level, the temperature decreases. Then there's a tropopause, which it stays constant for a bit. Then it starts increasing in the stratosphere. Then when you get to the mesosphere, it starts decreasing again. And then when you get up to the a little bit higher, to about 90 into the thermosphere, the temperature starts increasing and just starts really, really increasing because of solar radiation. So that's kind of ties us into terrestrial weather down there in the troposphere. Now, I've commented that the troposphere goes up to 30,000 feet. Well, I've been on airline flights where thunderstorm tops are something around 70,000 feet. So the big thunderstorms can get even higher than the troposphere. They get into the stratosphere, which is very impressive. You don't, of course, want to fly through one of those. Now, the other thing we have to look at is space weather. That's because space weather, which is solar radiation and disturbances to propagation, that affects about 60 kilometers and higher in altitude. That's the 60 kilometers is the bottom of the D region. And also space weather that can result in ionization in the F2 region. And that's pretty critical, the solar radiation to do that, assuming there's no disturbances to propagation. So 6-meter terrestrial weather. Both terrestrial weather and space weather both affect 6 meters. For terrestrial weather, that's where tropospheric ducting comes in. Now take a look at that plot. On the left side is a normal atmosphere. You note that it only goes up to about 2,000 or 3,000 kilometers, 3,000 meters, which is about 3 kilometers. And you can see that the temperature just decreases very steadily. And that's what the atmosphere will do, the temperature in the atmosphere will do if there's no tropospheric ducting. So tropospheric ducting requires a temperature inversion in the troposphere. And that's the curve on the right. And you can see what happens is initially the temperature starts decreasing at about 1,000 meters. Oh, it starts increasing again. And then probably at about, 1,200 kilometers, it starts decreasing again. So there's a temperature inversion. You can see how the depth is defined from when the temperature starts increasing and then starts decreasing again. In that example, the depth is 200 meters. The depth is very critical versus the band. Temperature is the primary parameter, but humidity is also involved, and that can get kind of complicated. We can measure temperature inversions with radiosondes, which are balloons that are launched twice a day at many locations around the US, and they take all that data, and it's really easy to see a temperature inversion if you look at some of the data there. So here's a chart that kind of tells us how much of an inversion, temperature inversion, what's the depth of the inversion needed on 6 meters? Well, you can see there's the required depth from 24 gigahertz all the way down to 6 meters. You can see 6 meters requires an inversion depth of about 450 meters. Okay, 2 meters, of course, doesn't require as much of a depth. 70 centimeters, which is 420 megahertz or so, that requires even less of a inversion depth. So I'm only aware of one tropospheric opening on 6, and that comes from K7CW in Washington back in the early 1970s. That was during the ARRL June VH contest, and he worked lots of, heard lots of stuff and worked lots of KL7s all the way down into Southern California too. There doesn't seem to be any other explanation than tropospheric ducting. Tropo on 6 is kind of rare, so you may not see it. Even if there's a temperature inversion, the 2 stations need to be in the right place to get into the tropospheric duct and then have the signal come out of the duct and go to the other station. So it's kind of rare. Now, here's a way to determine if there may be tropospheric ducting on 6 meters. Here's a Hepburn tropo forecast. And there's the website there. The URL is above the map. You go there and you can select a region of the world. You can select, Europe, Eastern North America. You can see I selected Western North America. That's up in the upper right corner of that map, WRNNO America. That's Western North America. You can see where Utah is. And basically, there's probably no possibility for Utah. And that has a lot to do with the winter months. In the summer months, you'll see many more opportunities for the inland areas. So as we start approaching summer, start taking a look at that. And if you're interested in some long distance 6 meter work, maybe you'll be pleasantly surprised. There's a chart, there's a kind of the color coded numbers that tell how good tropospheric ducting may be. You can see down on off the west coast of Mexico, there's a very intense probability. Of course, you got to have someone else on the other end out in the Pacific Ocean. So that may be a problem. They talk to a ship out there or something, I guess. But like I said, wait for the summer. You'll see a heck of a lot more opportunities for the inland areas. Okay, 6 meters, of course, depends on terrestrial weather. It also depends on space weather. Where we are right now in solar cycle 25, or where we are in a solar cycle is very critical. Very high sunspot numbers give the best chance of F2 propagation. We don't get much propagation on 6 meters via the E region. Of course, the D region, all it does is hurt, but it doesn't hurt too much because as you go higher in frequency, ionospheric absorption is less and less. So that's good. Just as a comment, sunspot numbers and 10.7 centimeter solar flux are correlated in the long term, not daily. There's not a good correlation between sunspot number and long term and 10.7 centimeter solar flux on a daily basis. But on a much longer basis, there's a good correlation. So what you want to look for 6 meter propagation via the F2 region is the 10.7 centimeter solar flux needs to be greater than 200 for more than just a couple days. For several weeks or a month would be really good. Then you probably have some 6 meter propagation via the F2 region. And that'll occur in the fall and winter months. Remember I said the MUFs, maximum usable frequencies, will decrease in the summer. So we don't have much F2 propagation in the summer unless we're at a really big solar cycle like 19. But don't forget about sporadic E in the summer and in December. There's a plot of the probabilities versus local time. You can see those green shaded areas. Those are the highest probabilities. This data is kind of old, from 57 and 58, but it's still valid. You can see during the summer months, the late morning is the best chance for sporadic E in the summer months, and early evening is the other. You can see the December probabilities are good during the early evening. And of course, I've seen some reports on some sporadic E. You got to be in the right place, and the cloud has to be in the right place, but still worth checking out if you're in some of the green areas versus local time of day. Okay, what about 2 meters and 1.2 meters, 220 megahertz? For all intents and purposes, these two bands are not affected by space weather. Tropospheric ducting is the major long distance propagation mode on these two bands, and also on 70 centimeters for 20 megahertz. But that's not VHF, that's UHF. July 24 and 5 of 2021 appears to have offered a coast-to-coast tropo on 2 meters. Coast to coast meaning the East Coast to the West Coast. And I downloaded some radiosonde data from Omaha, and it tends to support the fact that this probably was 2 meter tropospheric ducting. If we go back to that chart about what depth is needed, you can see on 2 meters, it's greater than 200 meters. And there's the data that came from the balloon that was launched from Omaha at 0000 UTC. You can see way over on the right, the temperature was about, maybe about 32 degrees at, 400 meters or so. And it starts decreasing, and it got down to about 21 or 22 meters at about 1,400 meters. But then it started increasing, and it increased to about, maybe 24 degrees C. And you can see where the inversion depth is. It's from 1377 meters to 1638 meters. And that's a depth of 261 meters. Then, of course, above that, temperature just started decreasing as we got higher and higher. And I'm not sure what happened up at 42, 50 meters. If there was something in the data or whatever. But that's a good example. I also looked at the Vandenberg radiosonde data, and it also showed a good depth for 2 meters. And I looked at, I think it was the radiosonde out of Buffalo, New York, and it had a nice depth for 2 meters also. So that's the best guess that it was tropospheric ducting from coast to coast, which is pretty interesting. Okay, that's about it for what I was going to talk about. Here's some references if you care to go dig into propagation more and more. The propagation chapters of the ARRL handbook and the antenna book. The ARRL does have a propagation book called Here to There, Radio Wave Propagation. It's on the ARRL store. Bob Brown, NM7M, he's a silent key, but he wrote a little book, The Little Pistol's Guide to HF Propagation. It's a very easy read, gets into a lot of stuff. It's out of print, but it's on my website there at that URL. CQ came out with the 4th edition of their CQ shortwave propagation handbook. Unfortunately, CQ's out of business, and therefore that handbook is out of print. That's too bad, because it's a good one. and I'm not sure where you get it. I would hope that maybe someday that the ARRL would pick up that book and sell it, but I don't know if that's going to ever happen. We'll see. G0KYA over in the UK, he's got a good little book, The Radio Propagation Explained. You can buy that off of Amazon. You could probably get it on the RSGB, Radio Society of Great Britain website. And of course, my website, k9la.us will give you lots of information. So cycle 25 has surpassed cycle 24. This is great news for 15, 12, and 10 meters, and even 6 meters. We've had 6 meter F2 propagation already, so hopefully we'll see some more. Use the internet to see what's going on right now on the bands, so you don't have to guess. But all I can say is get on the air and have fun. Use FT8 for its advantage over SSB and CW. That really helps with modest stations that have run only 100 watts and modest antenna. Now, my wife Vicki and I are going to be going to the Cayman Islands. That's why I'm trying to keep this short. We have a 6 a.m. flight tomorrow morning out of Fort Wayne. We should be on the bit for a bit in the ARRL 10 meter contest this weekend. Vicki, of course, will be on sideband somewhere between 28.3 and 28.6 or so. I can't give you a specific frequency. All I can say is, there's going to be a lot of people on 10 meters this weekend, I bet. All you can do is look for a YL and maybe it's her. So that's all I had. If there's any questions, I'd be glad to answer them.
A great presentation, Carl. Thank you.
You're welcome. If you're talking, I can't hear you.
Sorry about that. The hand mic was muted.
Oh, okay.
I did notice that over the summer, the 40 meter band was working really well, and then the 10 meter band is working well now, but during the summer it wasn't. But that you're saying that wasn't because of the solar flares, that was just because of the season.
That's right. It's very noticeable. I could have put it up a plot on the maximum usable frequency by month for a path from K9LA to Great Britain or whatever. And you can see that during the summer months, the MUF's going to get down to the low 20s, 20 megahertz. So that's, of course, not high enough for 28 megahertz. But that's why I keep saying, get on these higher bands during the fall and winter months. And we'll still have a great propagation, probably up through March and April, maybe even May, before it 10, 15, and 12 kind of go away for a little bit, for a couple months.
Oh, I had one more question too. I do like
Sure.
the solar flares, like learning about them and all. Those books that you mentioned, do they talk a lot about them?
Okay, what was the end of your question, please?
I like learning a lot about the solar flares. I
Okay.
don't know why. I'm just really interested in them, and I wasn't sure. The books that you mentioned, do they talk a lot about them?
Oh, yeah. Yeah, that's some, disturbances to propagation are for some very basic issues with propagation. So they're going to be talked about, yes.
Any other questions?
I guess that's it.
I was making sure a kitty cat wouldn't walk across the.
Well, there are no questions, so Carl, I guess we're
Okay.
done. Thank you
Okay.
so much for being here with us. We appreciate it.
I will Probably send the I'll send the PDF to Mike, okay?
And enjoy your trip.
Oh, we will. I'm sure we will. Okay, have a good meeting, guys. And ladies and gentlemen, I should say.
All right. Well, we have other business to look at. Do we have any new members? Anybody here for the first time? Want to introduce yourself? Be brave. There you go. You first.
Hi. So, I'm Andrew, KK7OYV. I'm 15. I've been into radio for, licensed for a year. So yeah.
My name's Antone, and my call sign is KK7AEM, and I'm 14, and I've been in ham radio for about a year or two.
Excellent. We need more people of your age in ham radio. Glad to have you here. I hope you keep coming out. Anybody else? No more new guys. Okay. Has anybody upgraded since we met last? No? We don't have any new generals or new extras?
They need to come up with something better than extra. I definitely test for it.
Yeah, I know. I've been looking for it. It'll be super. Okay, we're going to move on to elections then. Do we have any nominations?
Well, you mentioned B's. I'm doing B.
Okay.
Yeah, for the, you know, that guy, what's his name? WYI or ARL? Yeah. You know him, yeah, his name is, Garth? Who? Is it Garth? Yeah, I know his name, but kind of like, so hard to remember in the movie. Garth, yeah. Yeah, Garth, yeah, call sign is,
Yeah, congratulations on becoming a VE, Mike.
seven, no, I like that stuff, man. It's like trying to help make more hands and upgrade units. Like work for community, man.
Okay, are there any nominations for board members before we take a vote? Okay, well, we'll pass that then. How many want to see our dues get raised? Raise your hand. How many want to see our dues raised? Nobody. Okay, good. We won't raise them.
We need to vote on the board the directors. All those in favor of the board as it now consists? Any opposed?
You know, we really can't hear you guys very much.
You got to talk into the microphone.
All right, we're looking for voting a member or the board of directors, and we taking a vote to vote for those members in the board that are currently constituted, and seems to be unanimous for those members who are present. Do we have
Aye.
anybody opposed online?
Just as a point of order, online can't vote under our current bylaws.
Yeah. They can't, if you're online, you can't vote. So just as a point of order, the voting here is unanimous to re-elect the board as it was constituted last year. So no change in the directors.
So this is why I have a board, to bail me out when I forget something. Okay, next month we're going to hopefully vote on another minor bylaws change. We have two engineers who are incredibly valuable to us. These are the people who keep our repeaters running and our remote stations running and design the equipment in these facilities when needed. And they're not actually voting board members at this time, but we feel that they are so valuable that we are going to make them voting members. So the next time we meet, we will vote on that change to the bylaws. Rick, what's going on in the bookstore today?
Well, pretty much the same as last month. Do have 3 titles here that are $10 each and one that's $15, if you're so inclined. Want to also promote the special order if you want to order something that's not here, like the new handbook. See me, you get a 10% discount. Club pays the taxes, and there's no shipping. So if you're interested in any of those titles that are not here, let me know. Thank you.
Thank you, Rick. This is a very valuable resource to us, and I feel that it's underused. Rick can order anything. You save on the shipping, you save on the taxes. Should take advantage of it. Before you leave today, walk by his table back there, take a look at what he's got for us today, and see if there's something there that you can use. Okay. We're going to do a drawing. And I'm going to break it in half here because Mike has donated to us a pristine amateur radio stamp.
Did everybody get a ticket?
Does everybody get a ticket?
Anybody who didn't get a ticket, let me know. Is your ticket in the bucket? There's one.
So we're going to do this one first, and then we'll go for the other ones.
All right. Pick it up. Oh, yeah, like, yeah. I've got the deck stack here.
Just one, Linda.
One, Linda.
Okay, if we call your name and you're really not interested in the stamp, then we'll put you back in for the other drawings and find somebody else. KB0STH, I think that is. Chris? G. Do you want it?
I'll take the stamp. I collect stamps.
Good deal. We got it to the right guy then. Find my envelope here. I'll buy it from you.
We can talk after.
Okay, how many do we need to draw now for the regular draw? How many? Yeah, how many? 8. 8? Okay, Linda, draw 8, please. The prizes are on this table over here. It is first come, first serve.
The end of the table, not the middle.
Yeah, not the middle. The end of the table. Okay. KA7LTL. KG7GOW. Oops. KC7LNR. Come on down if you're called. KD7YIU. KK7OYV, is that right? Andrea? KI7MTI? That's you. Bruce, KC7DGN. Last one.
Oh, I wish I had my glasses on. That looks like N5 something PI.
This is one we're having trouble reading. Check your ticket numbers. The last three numbers on the ticket are 860. If nobody comes up, we'll draw another one. Okay, one more, Linda.
One more, Linda. Here you go.
Three more? Okay.
Here, Linda. All right. Go ahead. More.
Okay.
Well, one of those is mine, so.
Why don't you grab it?
Oh, yeah, we'll take one.
Give me these three.
Okay.
Or two?
Yeah, yeah.
Okay, I got two. KF7 OZK, Bruce, is that right? WA0 PFC, Jack. And we are done. Thank you, people. Go home. Be safe.
Thanks, Marv. Thanks, James, for all you do.
Yeah, thanks for joining us, Noji. Appreciate it. And all on YouTube. Have a good evening.
You too. So will the results of the election be posted somewhere then? I mean, it's pretty academic, but still.
Sorry about that. What was that, Noji?
Well, I was just asking, will the results of the election be posted somewhere, even though it's somewhat academic?
Yeah, they'll be posted. They will be posted on our website for sure.
Cool. Thanks.
You do it. Oh, goodness gracious.